Hi, I'm Megan, and today I'll be showing you the R to ChimeraX interface that I've been using to visualize my AlphaFold predicted structures, my RdRp. So first we can open ChimeraX, or you can install it. If you don't have it, I think it'll at least be easier than installing PyMol personally. So we can start by typing in the command remote rest start port. We can specify the port that I have over here. You don't have to specify a port, but it's just easier for this tutorial. So then it started. If you have the log open to the right, you'll see something, but I don't have it open. And then we can define the CX function over here in R. This function was inspired by some homework I did for Professor Stipa in a seminar course I took in first year. And yeah, and so now we can open our CIF file from AlphaFold from R into ChimeraX. So we can have the file path here, and then do CX, and then the open file. And look, it opens. So this looks sort of funky because I actually input both the RNA genome for my virus and the RdRp sequence into AlphaFold just because, the RdRp interacts with the RNA sequence. This may not be entirely accurate, of course, because there are a bunch of other factors going on in biology that dictate how these two special molecules interact, but it's sort of interesting anyway. So here, I want to annotate the A, B, and C motifs. So over in R, I can specify the ranges and then use this CX function to select these residues that I specified and color them with an RGB color. I did that for all three. And there, look. The ABC motifs are now colored. And then we can also color the RNA chain by its nucleotide. So notice that the /A corresponds to the protein, the /B corresponds to nucleotide in this model. And there, it's all colorful now. And then we can also do some fun stuff like change the lighting, and we can also just remove our selections. And then we can sort of look and examine and see how these two molecules sort of nestle together. It's these motif sequences again. So I can do that over here. And then I want to select everything that's 5 angstroms away from these motif sequences to see what they sort of interact with. And then I want to select just things on chain B to see how these motif sequences maybe interact with the RNA molecule. And then I can directly get the data into R through this interface. So I can assign the output value into the surrounding variable. And then I can just sort of pre-process the output and extract the nucleotide names. And then I can just do a simple bar plot of the nucleotide frequencies. And then I can open it and see there, look. You can see that there's a lot of uracils apparently around the ABC motifs. Cool. So now let's sort of hide the big RNA molecule because that's sort of blocking our view from the protein. And then let's do some amino acid level analysis. So I like histidine. So let's select every histidine in this model and everything that is 3.8 angstroms away from it. Cool. And then we can specifically select what's in A, because even though the B chain, which is the RNA, is invisible, it still exists. And then we can, again, assign the surrounding things into a variable in R directly. And then we can get some amino acid statistics from our command. And if we open up the R thing, we can see that, first of all, this bar plot down here that I created, we can see that histidine is around a lot of leucine and isoleucine uncharged, as well as lysine, which is interesting, which might be because they have similar charges and therefore in the similar domains and have similar functions. And then this AA stat plot also just shows the properties of these amino acids that we've selected. And you can see again, it's mostly nonpolar, which is pretty common. Yeah. Let's go back to looking at ChimeraX. And now let's relate this sort of back to my project a bit more. So I did a variant effect predictor on this protein over here. So let's get the data in. And it's already sorted from most intolerant to least intolerant to change. And then we can define colors. And then we can paste together a color command that will color each amino acid residue according to its rank in the variant effect scores. And then we can run the color command. It will take a minute or so. All these residues are colored, and I still have some stuff selected, so I can just write a command. Actually, you can just do it directly in the command line over here. You are using the interface doesn't limit you from using one or the other. So I can do select clear. And then, yeah, let's go to the full screen in ChimeraX. So here, basically the blue residues are more tolerant to change, and the red residues should be less tolerant to change. And we can see that, yeah, a lot of the blue residues are on the outside, which makes sense because more exposed residues are usually more tolerant to change. And yeah, that's a pretty interesting implication for this pretty naive variant effect predictor that I used. So this R to ChimeraX interface that I've been using is really useful. It's really helpful to produce reproducible structure manipulations, and I hope it can be useful for some other people.